How does heat drive global weather patterns? Imagine the Earth as a giant ball being warmed unevenly by the sun. That uneven heating sets the stage for all the weather we experience every day. When the sun shines on the Earth, it doesn't heat everything equally because of the planet's shape and tilt. The equator gets more direct sunlight, making it hotter, while the poles receive less, keeping them cooler. This difference in temperature creates a natural flow of energy that moves through the atmosphere and oceans. When the Earth's surface heats up, the air close to it warms, expands, and becomes lighter. This process is called convection. Warm air rises because it's less dense, and cooler, heavier air sinks to take its place. This movement of air creates wind patterns that shape weather systems. One of the main circulation patterns is called the Hadley cell. It starts with warm air rising near the equator, moving upward and toward the poles at high altitudes, then cooling and sinking around 30 degrees north and south of the equator. These currents carry heat and moisture, helping from clouds and bringing rain or dry spells. Oceans also play a big role in moving heat around the globe. Winds push on the ocean's surface, creating currents that carry warm water from the equator toward the poles. Meanwhile, cooler water from higher latitudes flows back toward the tropics. This exchange helps keep climate and weather more balanced across different regions. When warm ocean waters are present, they provide energy for storms like hurricanes, making them stronger and more intense. Heat also influences the water cycle. As the sun heats the oceans and land, it causes water to evaporate into the air. The water vapor rises, cools, and condenses into clouds. When enough water gathers, it falls as rain, snow, or storms. This cycle is essential for weather events like thunderstorms, droughts, and rainfall patterns. From a thermodynamics point of view, heat is the transfer of energy caused by temperature differences. The first law of thermodynamics says energy can't be created or destroyed, only moved or changed. Solar energy heats the Earth's surface, and this heat then moves through the atmosphere and oceans by conduction, convection, and radiation. These processes drive the circulation of air and water, shaping the weather patterns we see. So, in simple terms, heat from the sun causes air and water to move, creating winds, storms, and rainfall. These movements distribute heat around the planet, making weather change from place to place and over time. Understanding how heat works in this way helps us see why weather varies so much across the globe and why it keeps changing.